anyway, so the notes I sent, actually, they do have the answers in it, so so let's do it together, though. But here, basically, we have x squared minus minus 2x plus 3. Okay? So let's do that. Okay. So from here, we have a is 1, b, right, is minus 2, and c is 3. Okay? So again, it's just like before. We have to figure out what the vertex is. So we have x equals minus b over 2 times a. I'm just using the formulas again. That's all I'm doing. You know, the formulas from, let me see if I can get to it. Here, so this is what I'm using. I'm using this formula for the vertex. Vertex, right, is always going to look like this since we have this form here. We have to calculate minus b over 2 times a, and then do f of that. Here we go. Okay. So in this case, we're going to have minus b minus 2 over 2 times a, which is 2 times 1. Okay. And that's going to be actually 1. Also, because we have this negative and we have a negative up here, so those negatives are gone. You know, sap and sun rules. And so we get this. And now to get f of that, we have f of 1, which is 1 squared minus 2 times 1 plus 3. And, you know, that just turns out to be 2. So right away, we have the vertex, right? We have 1, 2. We have the vertex. Not only that, since we know what a is positive, we can easily get the range. Right? Just think about what's happening. Wait, let me get the pen first. Yeah. Right? You can easily get, well, I mean, we know since a is positive, the graph's going to open upward, right? Like this. You can see. So the vertex is going to be down here. The 1, 2 is down here. 1, 2. So the range, then, you can imagine, is going to go from the vertex all the way up to infinity. So the range, then, is going to be from 2, infinity. Okay? That's what we get here. Not only that, the axis of symmetry, okay? Remember, that's the vertical line through the vertex. So that's x equals the 1. Okay. And f of 0, of course, is 3. Again, you know, I didn't do the calculation, but hopefully you can see it, so to say. You know, if you replace x by 0, this term would be gone. This term would be gone. The only thing left would be 3. Hopefully you can see that. Yeah, I mean, yeah. Okay, so that's good. What's next on the list? Well, what's next is the X-Intercept. Now, this is kind of interesting, isn't it? Right? You can see from here that if we try the, the quadratic formula, we have negative b, which is negative 2, so we have negative 2, plus or minus the square root of negative 2 squared, minus 4 times 1 times 3, AC, over 2 times A. And, you know, we do the calculation and all that, but we get here, we get 2 plus or minus the square root of minus 16 over 2. Well, we have a square root of a negative, right? That's not a real number. So because that's not a real number, the quadratic formula tells us there are no x-intercepts. In other words, f of x here can never be 0 for real number x's. I mean, what's actually happening is the zeros are going to be complex numbers, but we're not studying complex numbers, so there are no x-intercepts here. So the graph is never going to touch or cross the x-axis. It stays away from it. And that's what's happening, as you can see. Here's the vertex. Here's the, what do you call it, the y-intercept. It never touches the x-axis, as you can see. If we did draw the axis of symmetry, it's going to look something like this. Okay. So we have that. So this is what we get here. Okay. And again, the range is from 2 to infinity. We saw that already. If you wanted to confirm that, you would, again, you want to see what part of the y-axis lies on the left or on the right side of the graph. And hopefully you can see that from here. You have 2, and up, and up, and up, and up. But basically you have everything from 2 up to infinity. So that's what the range is going to be. Yeah, that's good. That's what we get there. Are there any questions about that? I have another example we can do. I was hoping we would try let you try some of these examples, but I think the notes I sent have the answers in them, which was kind of silly of me. I mean, Friday we can always try some. Are there any questions? Okay, so let's do one more then. Got a few minutes left. Oh, no, there we go. Well, yeah, this is the next one, which is x squared minus 3x plus 2. This one's kind of annoying in that the vertex, as you can see here, is not going to be just an integer. It's going to be a decimal. Because we have a is 1, b is minus 3, c is 2, as you can see. We have x is negative b over 2 times a. So again, I'm just using the formula, right? You can see that there's a process here. So we have negative b over 2 times a, which in this case is negative 3 over 2 times 1. So the negatives are gone, but you have 3 halves, which is 1.5. Okay, that's good. So from here, what do we get next? Well, we do f of that, right? We do negative b over 2 times. Then we do f of that. And that turns out to be f of 1.5. And then if you plug that in, I use the calculator for this, you get negative 0.25. That's what we end up with. And so from there, we get our vertex. Now A is positive, right? So we can get the range right away. As before, it's going to be from the y coordinate up to infinity. So the range should be from negative 0.25 up to infinity. Again, A is positive here. We also have the axis of symmetry, right? That's the vertical line through, what do you call it, through the vertex. And we have f of 0, right? F of 0, right? If you plug it in, x squared becomes 0 squared, so that's gone. Minus 3x becomes minus 3, 0. So that's also gone. So we have plus 2. So you know what? Let me do that range thing. Again, we have A is positive, right? So the graph's going to look like this. I mean, you may not see the arrows drawn, but it's understood that it keeps on going. And for the range, this part here, that's the vertex. So that's, what is that? 1 point, let me see if I can draw it. 1.5 negative 0.25. Okay, so now we can get the range easily, right? It's going up, so it has to go from the vertex up to infinity, or that is the y-coordinate. So the range is going to look like this, as you can see. Again, we can wait until we see the graph, but even without the graph, we should be able to see what the range is. So we have that now, okay? Okay, that's good. Again, we get the X-Intercept. I mean, these are kind of nice, as you can see, mostly because you're taking the square root of a perfect square. That is, you have the square root of 1, which is just 1. So that's what we have here, right? We have minus b plus or minus the square root of b squared minus 4ac over 2a. Right, that's the quadratic formula. So I'm just replacing b by minus 3, a by 1, c by 2. Minus 3, that becomes just 3. Double negative. We have 9 minus 8. As you can see, that's 1. Square root of 1 is just 1. So we get some really nice x-intercepts. We have 2 and 1 here. That's what we get. And then once we have those, we put them all together, boom, we get the graph. And again, our confirmation's right. The range is from negative 0.25 all the way up to infinity. As you can see, if you went to the horizontal, if you went to the y-axis, you can see that everything above negative 0.25 is to the left or right of the graph. So, I mean, I'm not drawing the horizontal lines, but hopefully you can still see it. So, all right. I think we'll have to stop here. We have less than a minute anyway.